So we explore how to downgrade HTTPS website to HTTP, which allows us to see all the data the user was sending because HTTP traffic is in plain text. We could view usernames, passwords, and everything else that the user did. However, I also show you that this method does not work against websites like Facebook, Twitter, which use something called HSTS, HTTP Strict Transport Security. Let me explain why that happens and how we can bypass it. So, what is HSTS? Well, modern browsers like Chrome and Firefox come with a built-in list of websites that should always be loaded over HTTPS. Even if we try to send back an HTTP version of the site, the browser ignores it. This list includes popular websites like Facebook, Twitter, and others. And once we become the man in the middle, there is nothing we can do because the browser locally checked this list. The browser does not even send a request over HTTP. It directly uses HTTPS and only accepts HTTPS response for these websites. So, how do we can bypass this? The only practical solution is to trick the browser into thinking it's loading a different website. We do this by replacing HSTS link with similar looking but slightly different domains. For example, instead of facebook.com, we can replace it with facebook.com. I know this seems obvious when you hear it, but visually the letters R and N together look like M in the browser's URL bar. Another example is replacing twitter.com with twitter.com using just one T instead of two. This might sound confusing right now, but don't worry, I will show you exactly how this works in practice. I have my Kali machine ready and we will be using an HSTS hijacking caplet with BetterCap. In the previous lecture, I show you how to downgrade and place this caplet in the right directory. Here how it works. The caplet is stored in user share BetterCap caplets HSTS hijack and is named HSTS hijack.cap. Right click and open it in a text editor. You will see pre-configured targets and replacements. Target are the website using HSTS like twitter.com and .twitter.com. The wildcard means it's target any subdomain of Twitter. Replacements specify the spoofed domains. For example, twitter.com becomes twitter.con. You can modify this replacement if you want. For instance, you could use twitter.com with a single T instead of con. It's flexible. Now, it's crucial to ensure that the DNS spoof domains are set exactly the same as the replacements. I literally copy and paste them to avoid mistakes. Once everything is configured, we are ready to run the attack. Now I close it and open terminal. Once everything is configured, we are ready to run the attack. The process is almost identical to what we did in the previous lecture with ARP spoofing and running BetterCap. Here is a step-by-step breakdown. Run BetterCap with the command we used last time. And load the HSTS hijack caplet by typing HS and pressing tab to autocomplete. Once it's running, switch to the target machine. Let's use a Linux machine running the latest version of browser. Now, on the target machine, I am going to open browser. And first of all, we clear the browsing data by pressing Ctrl+Shift+Delete and clear all. Now, I enter www.linkedin.com. As you can see, the website loads in HTTP. And I click the signing button and try to sign in s3cloud@gmail.com and password 1234567890. Now I press the signing button. Let's move to our Kali machine and check what we can capture it. As you can see, we successfully captured the username and password. This method allows us to bypass HSTS, but it's important to note that it only works under specific conditions. The user has to first go to the website that does not use HSTS before visiting the target website. So, while this is a clever trick, it's not a full solution for bypassing HTTPS protections, but it's still very effective in the right circumstances. In the next lecture, we will dive deeper into other techniques like JavaScript injection to extend this attack. Welcome to this lecture. Today we are diving into DNS spoofing, what it is and how you can perform this attack using BetterCap. Let's get started. First, let's quick understand DNS. Think of DNS as the internet's phone book. When you type a website's name like google.com into your browser, DNS converts that name into an IP address, the unique location of the server where the website's files are stored. For example, when you request google.com, your browser talks to a DNS server which returns Google's IP address, allowing your browser to load the site, which returns Google's IP address, allowing your browser to load the site. But what happens if we are the man in the middle? Instead of letting the request go straight to the DNS server, we intercept it first. And now, instead of returning the real IP of the website, we can respond with any IP event. That means we can redirect user to fake websites, backdoor pages, or even hijacking software updates. We will cover more advanced examples in future lectures, but for now, let's focus on running a basic DNS spoofing attack using BetterCap. In this demo, we will redirect requests from a specific website to our own local web server. Now let's move to the Kali machine. Before running BetterCap, we need to set up a web server on Kali Linux. Kali comes with Apache 2, a built-in web server. So let's start that with the command. Type command service Apache 2 start. If there are no errors, it means the web server is running. To check this, we need to find the IP address of our Kali machine. We will use the ifconfig command. Our IP is 192.168.73.131. Now, when I type this IP into a browser, you will see the default page of the Apache web server. I'll copy that and open browser and paste our IP address and hit enter. You will see the default page of the Apache web server. Now open the file where this index files are stored. So open the file and press Ctrl L and type where www.html and enter. The main file loaded by default is index.html. Let's quickly edit it to display a name. As you can see, here is the code of index.html and I will remove it and type S3 cloud hub and save it. Now when I refresh the page, you can see the name of S3 Cloud Hub has appeared. This is what we will redirect our target to during the attack. Let's use a target machine for this demo. When we visit a website, for example s3cloudhub.in, you will see the actual website load as expected. Now let's see how we can intercept and modify this using BetterCap. We will start BetterCap. Now let's see how we can intercept and modify this using BetterCap. So let's move to our Kali machine, close it. We will start BetterCap just like we have done in previous demonstration. With the spoof caplet loaded, we can intercept and modify the data as it passes through our machine. So run the BetterCap and type help. As you can see, DNS spoof is now not running. The module we need is DNS spoof. Let's check the option by typing help DNS spoof. Help DNS spoof. The first option we need to set is DNS spoof address, which tells Bettergap where to redirect the target. By default, it's set to our machine's IP address, so we will leave it. Next, we enable dnsspoof.all so that Bettergap respond to all DNS requests. We do this by typing set DNS spoof all true and hit enter. Then we need to specify the domains we want to spoof. In this case, we will targeting st-cloudhub.in and all its subdomain using a wildcard. So I will type set DNS spoof domains st-cloudhub.in and hit enter. Once everything is set, we start the DNS spoofing module by typing DNS spoof on. As you can see, Bettergap is now actively spoofing DNS requests for st-cloudhub and redirecting them to our IP address. Let's head back to our target machine and test it. Remember, if you have recently visited the site, you might need to clear your browsing data for the changes to take effect. Now when the target visit st-cloudhub.in, they are redirected to our local website with the name of st-cloudhub. The attack is successful. This DNS spoofing attack can work on most websites, even those using HTTPS, but there are limitations. For example, sites using HSTS won't be vulnerable since the browser maintains a local list that forces HTTPS connections. Though we have shown a simple text message st-cloudhub, and DNS spoofing has many real-world applications. You could redirect users to phishing pages, fake login screens, or even deliver backdoor software updates. We will explore these advanced uses in future lessons. Hello everyone and welcome back. So far we have explored some powerful techniques once we become the man in the middle. We have seen how to monitor everything that happens on the target device. Websites, usernames, passwords, images, everything they load on that browser. We have also seen how to redirect the target to different websites using a DNS spoofing. But there is another existing capability that we will explore today: modifying web pages as they load in the target's browser. Since we are intercepting all data as it passes, we can inject our own code into these web pages and make the browser execute. Now, HTML controls the structure of the page, but it's JavaScript that brings real power, allowing us to manipulate the entire page dynamically. We can add, remove, or modify elements on the pages, replace links, and even hook the target's browser to other exploitation frameworks. In this demo, I will show you how to inject a simple JavaScript code into any pages the target visits. From here, we will build on this foundation. to perform more advanced actions. To begin, I am going to open a text editor on my Kali machine. So first of all, we move to the Kali machine and open a text editor. We will write a basic JavaScript code to display an alert message. The code will simply look like this: alert JavaScript test. All this script does is display a pop-up saying JavaScript test. Now I will save this file as a alert.js in my root directory. Next, we will use Bettergap to inject this JavaScript into target's browser. Specifically, we will modify the HSTS hijack plugin. Let me open the plugin configuration file located in user share Bettergap applets HSTS hijack and open the HSTS hijack.cap file into a text editor. This file already inject a keylogger JavaScript file, but we will add our own script by editing the payload section. I will insert this line to inject our JavaScript file into every page the target loads. So type it colon and paste the path of alert.js. I copy that and paste here write name of the file and also add the comma here. This tell Bettercap to inject the alert.js file to all web pages. I will save the changes and now we are ready to test it out. Now I will run Bettercap with the same command we have been using to launch ARP spoofing and put ourselves in the middle of the connection. With Bettercap running smoothly, I will launch the HSTS hijack plugin. So press HS and tap for autocomplete. Once it loads, it will begin injecting the JavaScript payload, which include both the keylogger or our alert.js file. Now whenever our target loads any web pages, they will see the alert message. Let's check it. Open the target machine and check it out. Now I will be enter worldweb.com. As you can see, the pop-up are shown JavaScript test and press OK. Now try another one. Let's check into another website. Type s3cloud.in. As you can see, the pop-up messages are appear. This simple demo shows how easy it is to inject JavaScript into any pages loaded by the target browser. This is just the start. By injecting JavaScript, we can do far more than display an alert. We can steal data, modify content, and more. In future videos, we will dive deeper into how to create more functional and stealthy JavaScript injection that can bypass security and remain undetected. This will give you a better understanding of how attackers exploit web vulnerability. So stay tuned for the next session. Where we will explore advanced JavaScript exploitation techniques and browsers manipulation. In this lecture, we are going to talk about Wireshark, an essential tool for network administrators. Now, Wireshark is a network protocol analyzer, not a hacking tool. It's designed for network administrator to monitor their networks, ensuring everything is working correctly and detecting any suspicious activities. Wireshark works by capturing network traffic through your selected interface. It could be your wired or wireless card. Once you select an interface, Wireshark starts logging all the network traffic flowing through it. This data can then be analyzed in detail using its graphical interface, which provide powerful filtering and search options. Wireshark lets you filter packets based on protocol like HTTP, TCP, or even search for specific data such as cookies, post requests, or GET requests. This flexibility is why it's a popular tool for network troubleshooting. Now, let me show you how Wireshark works. So, first of all, we open terminal or from application menu, open Wireshark. We will launch Wireshark, select the interface connected to my network. In this case, ETH0. If I open a browser and visit google.com, you can immediately see the traffic being generated. But remember, Wireshark only captures traffic going through your own interface. For instance, traffic generated by other device, like my another Kali machine here, won't appear unless we perform something like ARP spoofing to become the man in the middle. This is where techniques like ARP spoofing come in handy. By becoming the man in the middle, we can intercept and capture the traffic of devices we can targeting. In future videos, we will explore creating fake access points and further diving into ARP spoofing. Here is an example using Bettercap for ARP spoofing. Run the Bettercap. Once the spoofing is successful, Wireshark will be capturing all traffic from the target machine. Now I open a google.com to our target machine. As you can see, the traffic from that device is now being logged by Wireshark on my Kali Linux machine. To wrap up, Wireshark is a tool for logging and analyzing packets that pass through your interface. It's powerful for network monitoring, but is not inherently a hacking tool. In the next video, we will take a deeper look at how to use Wireshark for packet sniffing and analysis. I will open my Kali machine and open Wireshark. Let's explore the capture option in Wireshark. First, you will see a list of network interfaces, each showing the amount of traffic passing through. In this case, traffic is occasionally being generated on ETH0 from the target machine. You can select the interfaces you want to capture from. Wireshark allows capturing from multiple interfaces at once by holding the control and selecting them. For this demo, we will focus on only ETH0. Next, we will move to the output section, where you can choose to store the captured packets. If you don't plan to analyze the packets immediately, you can save them and revisit them later using Wireshark. Now that we have selected ETH0, I will click Start to begin capturing. Any traffic flowing through ETH0, whether it's image, messages, cookies, or any other data, will be captured and displayed by Wireshark. To see some actual data, I will generate traffic on the target machine. Before that, I will head back to BetterCap and use the HSTS caplet to downgrade HTTPS HS and hit enter. This way the data will be unencrypted and we can inspect it easily in Wireshark. Now I will run the caplet and return to the Wireshark. Now let's generate some traffic by visiting a website. So I open my target machine. First thing is, we need to remove browsing data by pressing Ctrl+Shift+Delete and clear now, and open some HTTP website like google.ie. Now I will search for s3cloud.in. Since everything is loading over HTTP, we will be able to inspect and analyze it clearly. Let's go back to Wireshark and see how the captured data looks. I'll stop the packet capture and now we can scan analyze the result. I will stop the packet capture and now we can analyze the results. Each row in Wireshark represents a captured packet. You will see a various columns including packet number. Each packet has its own number, shows when the packet was captured. And now we can analyze the results. Each row in Wireshark represents a captured packet. You will see a various columns including packet number. Each packet has its own number. Timestamp shows when the packet was captured. Source, the device or IP address the packets originated from. Destination, the destination IP addresses of the packet. Protocol, display the protocol used like TCP, ICMP or ARP. Packets are color coded. Green for TCP, dark blue for DNS, and light blue for UDP. Although we don't have any UDP packets at the moment, black indicates problematic TCP packets. So we have captured a lot of data, not all of it may be relevant to what you are looking for. In the next lecture, I will show you how to filter out unnecessary packets and focus on the ones that matter so we can extract useful information from them. Stay tuned for the next video, where we dive deeper into packet filtering and analyzing with Wireshark. Hello friends, welcome back. I am going to walk you through a Wireshark and show you how to filter packets and focus on the useful stuff. You will be learn how to trace specific packets, understand what they mean, and dig deeper into each one to extract valuable information. So let's get started. Alright, so as you guys know, we have been working with a target computer and most of the traffic we generated so far is HTTP. Now, what I am going to show you is how to filter all that traffic so we can only see HTTP packets, which are much easier to analyze. It's super simple to do this. Just come over filter section and type HTTP. As you can see now, Wireshark is only showing us to HTTP traffic. This traffic is typically sent by browsers. And since we have downgraded HTTPS to HTTP in our demo setup, everything the target does in the browser will now appear as HTTP, whether they are watching videos, browsing websites, or looking at images. Wireshark will capture all of it. So let's break down this packet here. We can see this request was sent from the target's computer's IP address to a public IP address on the internet. So this packet is going out to a server, not staying with the local network. When I double click on this record, you will see all the details of the packet pop up. We have got information about the frame, which include things like the size of the packet and the interface it was sent on, and the exact timestamp of when it was sent. But more importantly, if we look down here, we can see the source MAC addresses and the destination MAC address. Remember when we talked about packets earlier, every packet travels from a source MAC to a destination MAC. This is how devices identify each other on a network. So this packet went from our target's IP to server's IP on the internet. Cool, right? Now, if we look at the transmission protocol section, it gives us port information. This packet was sent to port 80, which is the default port of HTTP traffic. Now, the most important part for us is the HTTPS section. This is where the real data is. If we expand this section, we can see the full content of the packet. For example, this packet contains a GET request sent to a google.ie. So, this is literally when the target type google.ie. For example, this packet contains a GET request sent to google.ie. So, this is literally when the target type google.ie into their browser. Wireshark capture it all. You can even see the HTTP headers, which give you more detail about the request. This is super useful if you want to understand exactly what is being sent and received between the browser and the website. Now, let's say you want to follow an entire conversation between the target and the website. Wireshark lets you do that too. Just right click on the packet, select follow and HTTP stream. Here we go. Wireshark shows us both the request and the responses. For example, we can see that the responses to this request included a PNG file. For example, we can see that the responses to this request included a PNG image. And if you scroll down, and you can even see the raw data of the image being transferred. Now, if we keep scrolling down, we can find other types of data. For example, here we can see a JavaScript file being loaded by Google. And here is another GET request where the target searched for something. Let's click on it and check it out. Let's click on it and check it out. As you can see, the target searched for LinkedIn on Google. Wireshark captured the full URL include the search terms. So we can literally see exactly what the target typed in the search bar. Alright, so that's a quick introduction to using Wireshark to filter and analyze HTTP traffic. We have seen how to focus on HTTP packets, trace the path of data, and even extract the exact data sent in browser request. Don't worry if this seems a bit overwhelming at first. We will be using this technique in future lectures to dive deeper into packets analysis and find some really interesting stuff. Welcome back everyone. In this lecture, we are going to dive into using Wireshark to discover data sent through forms, specifically focusing on how usernames and password can be captured when someone fills out a form on a website. This will give us a good understanding of how data is transferred during login attempts, especially in insecure environments. Now I have already got BetterCap running in the background, so I am acting as the man in the middle. Let's switch over to Wireshark, where I will start a new capture. I have set the filter to only capture HTTP packets, so it's going to show me only the HTTP traffic. Let's navigate to a test website for this demo. So it's going to show me only the HTTP traffic. Let's navigate to our target machine and open browser, and let's navigate to our test website. For this demo, I am going to use oneweb.com. Keep in mind that this is an HTTP website, so the data we send here is not encrypted. Open the first link. As mentioned in previous lessons, we know we need to target an HTTP login page, but don't worry, we have also covered how to bypass HTTPS and HSTS. So if you need to downgrade a site from HTTPS to HTTP, that's something we are already learned. For this example, I will log in with the username admin and the password is 123456. Once I hit login, Wireshark should capture all the packets related to this transaction. Now that we have done, let's try something a bit more advanced. We will head over to a site that uses HTTPS. Like linkedin.com. linkedin.com. I will downgrade it to HTTP, and once that's done, we will try to capture login data as well. Click signing button for login. And I will log in with a sample username and password. Let's use s3cloudhub@gmail.com and enter password 1234567890 and press signing. Now back to Wireshark to analyze the data. Where things get interesting. I will stop capturing now, and what we need to focus on are the post requests, login forms, and most form submission and data using post. So if you are hunting for login information, this is where you should look. Scrolling through, we can see a post request to the login page on oneweb.com. Let's expand that and take a closer look at the HTML form data. As expected, we see the username as an admin and the password as a 123456. Clearly visible. Now I close it. Further down, we find the post request for linkedin.com. As you can see, here is the login form. Press double click and let's expand this. And scroll down to the HTML form data. Again, we can see the login credentials. Here is the username s3cloudhub@gmail.com and here is the password 1234567890. This demonstration shows how powerful Wireshark can be when it comes to capturing data flowing through a network. Even though BetterCap is great at sniffing password, sometimes it might miss filtering out usernames or other details. But with Wireshark, we capture everything that passes through our network interface. Now I minimize the Wireshark, and one cool thing you can do with BetterCap is to save all the data it captures into a file. You can do this by modifying the caplet configuration. Open our caplet, locate our caplet file and open it into a text editor. So add the command here and type net.sniff.output/root/capture file .cap. Press Ctrl F to save it. This will store all captured data into a cap file, which you can then open in Wireshark for further analysis. This is really handy if you are working on a resource constrained device, like a small laptop or even a phone. One last tip, Wireshark's find features is incredibly useful. You can use Ctrl F to search for specific terms in the captured packets. For example, if you are looking for a login attempts for a username s3cloudhub, just search for the keyword s3cloudhub. This feature makes it super easy to find login names and specific tags or any other details that may have been captured. And that's it for this lecture. I hope this gives you a clear understanding of how to capture form data, including usernames and passwords, using Wireshark. Remember, always practice ethically and legally. Welcome back everyone. In our previous lecture, we explored how once we are connected to a network, it's practically game over. By leveraging techniques like ARP spoofing, we have been able to redirect the flow of network packets, effectively making ourselves the man in the middle. This allows us to spy on users, steal their credentials, and even redirect them to malicious websites. What you have seen so far is just the beginning of what you can do when you are in the position. In this video, we are going to take it up a notch. I am going to show you another powerful method to become the man in the middle without needing to exploit ARP or any other protocols. And guess what? Once you are the man in the middle, you can execute all the attacks you have learned so far and many more that you can explore in the future. Let's start by reviewing something basic. Remember the diagram we discussed earlier when we were learning about how networks work. The access point or the router is the only device with direct access to the internet. Clients like your phone or laptop send requests to this access point, which then forwards those requests to the internet, retrieves the responses, and send them back to the clients. But what if we as the hackers replace this access point with our computer? In other words, what if we create a fake Wi-Fi network that provides real internet access? When people connect to our network, we automatically become the man in the middle because we are now acting as their router. We won't need to exploit any protocols or run complicated attacks. People will willingly send us their data because they think they are connected to a legitimate network. This is where things get really interesting. By creating our own Wi-Fi networks, clients who connect to it will automatically send all their requests through us. And since we are the router, we can see everything they do. We will forward their request to the internet and send back responses, just like a real access point. But in the process, we will be able to intercept, sniff, and manipulate the traffic however we like once the clients are connected. We can launch all of the man-in-the-middle attacks we have demonstrated earlier without needing to run ARP spoofing or anything fancy. All you need is computer running Kali Linux, internet access, and a wireless interface capable of broadcasting the Wi-Fi signal. Now let's break down what you will need. Internet connection. This could be through a Wi-Fi, Ethernet, a 3G 4G dongle, or even a virtual interface. Wi-Fi interface, not just any Wi-Fi adapter, will work. It needs to be capable of running in access point mode. Once you have set up the necessary hardware, we will be able to start broadcasting our fake network. With this setup, our computer will act like a router. Clients who connect to the network will send all their traffic to us by default. So we won't need to worry about ARP spoofing. We are automatically the man in the middle. From there, you can run all the attacks we have covered previously or any other man in the middle attacks techniques, like sniffing passwords, injecting malicious code, or redirecting user to a phishing site. Now, you could configure all of this manually. For example, you could set up the wireless interface to broadcast the signal, configure routing between interfaces, and ensure that traffic is forwarded properly. However, since this is the ethical hacking course, I want to show you a faster and more straightforward way to achieving the small result. The tool we will use is called the Mana Toolkit. This is a powerful suite of tools that allow us to automatically create a fake access point, sniff traffic, and even bypass HTTPS in some cases. It has three main scripts to choose from. Start no upstream.sh. This creates a fake access point without internet access, which is not very useful for our purposes. Start net simple.sh. This sets up a fake access point with internet access. Next, start net full.sh. This also provides internet access but tries to automatically sniff traffic, which often fails. I recommend starting with not simple and then launching another terminal to run BetterCap for sniffing data and bypassing HTTPS, as we have shown in previous videos. Once our fake access point is live, clients will connect thinking they are accessing the internet. In reality, their traffic is flowing through our machine. We will use tools like BetterCap and Wireshark to analyze and manipulate the data. We can capture usernames, passwords, session tokens, and much more. This method of creating a fake access point is a powerful way to become the man in the middle and run a variety of attacks. It eliminates the need to exploit ARP protocols or other vulnerabilities. Clients will willingly send us their data,